So yes, my name is Lucia Payo. I work for N26, and today I'm going to be talking about reactive clean architecture and Android architecture components. Pretty long name, so let's cut it a little bit. Let's call it reactive clean architecture. So first thing we notice in this title is the word reactive. When I guess most of us think about reactive, we usually think about RxJava. This is a very popular library. Many Android developers use it, and it's so popular that there is other libraries that have integrated with it as well. This is the case of retrofit. So in retrofit, we can make an API call, get back a single observable, and then when this API call is ready, this single observable is going to emit. And we can do various things on it, like we can control the thread where things are executed, we can map it, then we can subscribe to it and do some stuff or fail, whatever we want or we need. And this is very powerful. This is indeed a very good way to use RxJava. And is it reactive? Well, yes, the chain itself is reactive because it will react whenever the API call comes back from the network, right? But there is other use case that I want to tell you about. So this kind of solution works well for some use cases, but there is one. This is when you have some data in your app, right? Most of apps have some data that then is reflected somehow in the feature, in the view. So what if we could observe this type of data forever, or as long as we need it, and receive a new version of it every time it changes? This is reactive as a system. It's a bit bigger. It's not just in the chain. It's thinking on the whole system as a reactive system. Okay, so this brings like an action-reaction type of system, and we'll see how that works in a minute. So next thing we notice in this title is the clean architecture. So most of us are pretty familiar with this already, and in Android this usually means these three layers, data, domain, and presentation. We've divided this architecture in these layers as well, so I walk you through them in a minute. And for that, I would like to have this example, so it's easier for me to explain it and for you to understand, hopefully. So the example is, let's try to build this list of credits in a view. And that's it. So we get the credits from some API, and we have to present this on a view on a list. Cool. So first layer is the data layer. It looks a little bit like this. We have a repository component on the top. This is the interface to the outside. Nothing else is visible from the outside, just the repository. And then under this, we're going to have the network services. This is usually the retrofit services that deal with the external source, on API, for instance. And then, on the other hand, we have a reactive store, which is going to deal with the persistence methods or a cache, and it's going to serve this data in a reactive way. So, first step, let's connect to the API. This is fairly simple. Just as I said, the retrofit service looks like this. I guess most of us are already pretty familiar with this. Then second step, well, actually 1.5, because I need to talk about reactive store first. How does this work? What is this component doing exactly? So we have this reactive store that is going to host key value pairs. And then it's going to expose like flowables. These are streams in RxJava 2. And we're going to have flowables for a specific value with a key that we pass there. So we have this get singular for the key. And we're going to have the get all flowable, which is giving like the list of all the values in the reactive store. As you can notice here, everything is wrapped inside an option. This is because RxJava 2 doesn't allow you to emit nulls. So yeah, we do this little trick to avoid the null. And then these flowables are designed to be infinite streams. So they are designed to never complete or error. That's the trick. So you can observe this thing forever. And it's the subscriber, the one that decides when it wants to stop observing or receiving updates, rather than the other way around, being the source saying, hey, I've completed, as in the retrofit type of observables. So in the other side, we're going to have the store singular and store all. This is like the action that is sort of going to feed the store in the other side. So how does it work? Well, it has two main characteristics. The first one is the streams are behavior streams. This means that as soon as you subscribe to them, they're going to emit the current state of the store. So let's say the store is empty and we have these subscribers. Well, they're going to receive none immediately. That's why we have the option. That's why we wrap it in an option, so we can receive this none signal. And maybe we can decide something later on, what do we want to do in this case. If there is something in the store, then we are going to receive the values wrapped inside the option. Then the second characteristic of the store is this action-reaction stuff. So we have the action as the store methods. When we store something, we want the reaction in the flow as well. So it's consistent. Every time we store, we get the reaction through the stream. Same way, if you store all, like a list, then you should get also the event. Okay, so the reactive store coordinates the process of putting data in a cache and/or persistence. The exact solution for this depends a lot on the requirements of the app. Sometimes we might want to have a database and then a cache on top, a memory cache on top. Sometimes this will be just shared preferences. It can be the file system. There is a lot of different implementations you can do here. And then second thing is the reactive store creates, stores, and feeds the streams. So these streams have to live somewhere. So this is the place. As you can see, the reactive store is a pretty big component. It's like the heart of the whole architecture. And it can be divided in different subcomponents, so things that take care of one single responsibility. But for this talk, it's not enough to actually dive into the details of this. So let's imagine we have already created this reactive store. We've seen how it's going to behave, and we're going to build on top of it. So we have this interface implemented with the store singular, store all, get singular, get all, as we saw. And now, second step, we are going to define this reactive store. So we have reactive store of key value. Now we have to define what type of key and what type of value. So it's going to be a string credit draft. The reason is because the ID in the credit draft is of a string of type string. So not rocket science there, so just string draft. And the third step is raw to safe entity mapper. What is this? Okay, so we have this external source, and the idea is that we're going to go to the external source, we're going to fetch the data from there, and then we're going to store it in the store. But if we look closely, we see how this is the call we do in the retrofit service, and it's actually returning a list of credit draft raw, while in the store, we're storing credit draft. This is different POJOs, and this is totally on purpose. So the idea here is that the external source is something we don't control. And yeah, we have contrast with the API, and the API should return some specific object, JSON object with some properties there, but sometimes there might be a mistake in the other side, and we might not get what they promised. So we want to fail as soon as possible on those cases. We don't want to propagate that further in our system because that can lead to a lot of time wasted. So that's exactly this mapping, what's happening there. We're going to map from the raw to the safe entity and make sure that what we store in this reactive store is in a good condition. So the rest of our system can totally rely on it and not worry about further check-ins or anything. So we're going to have something like this. As you see, it's just a function. So it has an input of the credit draft raw and an output of the credit draft. Cool. So we have all the little pieces now, or not so little for the reactive store, but we have everything we need to put all of it together in the repository class. So the repository class is going to get the store, the credit service, and the mapper we just saw. And then it's going to expose a couple of methods. The first one I'm going to talk about is this one, get all credit drafts. As you can see here, it's just store.getAll. So it's just bridging directly to the reactive store. Nothing very interesting here. But for the fetch, this is more interesting. So in the fetch action, everything is going to start in the credit service. So this is the retrofit service, the external source. We're going to fetch the credit drafts from the external source. We're going to control where everything is executed, of course. Then we're going to map from raw to safe each of these credit drafts that we get. And then we're going to put all of it in the store. And then we are going to put it to completable. The thing here is that fetch is like the action, and the get is the reaction. That's why we don't propagate the values that we just fetched through the fetch function or the method, because we want to define our system in this way. So if you want to consume the data, you go to the get. If you want to act on the data, you go to the fetch. Okay, so now we have the data already done, and we've built this repository. And we are going to build the next layer on top. So the main component of the domain layer is the reactive interactors. So it coordinates interactions with the repository, and it can be seen as a reactive use case. It's similar to the use cases in clean architecture, the most common ones, in the way that the interactor needs to do everything that is possible or like it can do to fulfill this use case. We'll see a little bit more in detail what this means. So let's say we create this retrieve credit draft list. This is the interactor, okay? This blue box in the middle. And this thing is hooked to the get method in the repository. And it can act as well over the repository, okay? So it has access to the repository, both to consume and to act. And then it's gonna, inside, it's gonna create this stream for the presentation to observe. And it's gonna clean it up and make it nice for the presentation to observe. So, okay, we can represent the input and the output of the interactor like this. The input is the repo.get, right? That's the line on the top, and that represents the flowable that comes from the repo.get. And then we're going to have another flowable as the output of this interactor. And so whenever a subscription happens, we said that the repository is going to meet as soon as possible, right after subscription, with the state of the store at that moment. So let's imagine the state is empty. So we're going to get a none. What do we do in this case? Well, this box is representing just like a method, something that is happening in the interactor. So inside this method, this none is going to be evaluated, or the emission, better said, like the emission from the get, the event from the get is going to be evaluated. If it's none, well, we need to fetch. So it's going to trigger a repo.fetch. And in this scenario, two things can happen. One is that we get an error. In that case, we want to propagate it. We want to let the presentation layer know there was an error with the fetch, there was a problem, so maybe the presentation can decide, okay, I want to show an error message or something. In the case that everything is fine and we receive the complete event, then this method is just going to forward the event as it's a none. And then we're going to filter it out, because we don't really want to expose this. Like, the presentation is not interested on the little things that have to happen in order to get all the credit drafts. It just wants the credit drafts. So we triggered a fetch, right? So eventually, we get the event in the repo get, because that, if you remember, that's how it worked. Like, action in the fetch is going to trigger a reaction in the get. So we get the sum now. We get events, and it's just, this method is just going to forward it. It's going to evaluate it. Okay, it's a sum. I don't need to fetch it. I don't need to do anything. Just send it over. And we're going to unwrap it, because, yeah, we don't want to propagate the option further. We just want the value inside the option. In this case, it's going to be credit drafts. And I don't know why I put an S there, but okay. So this is how the interface for the retrieve interactor looks like. As you see, it's pretty similar to the typical use case in the clean architecture. with the difference that here we have a getBehaviorStream method that returns the flowable. So the idea here is not that you execute the use case, is that you just sort of, you take the stream from the repository and combine it with other things, make decisions and so on, and like continue with the stream up to the presentation layer. Cool. All right, so we have done now the domain layer, and we're going to go with the presentation. So for the presentation, we're going to have the credit dashboard view model. That's how we call the fragment, credit dashboard fragment. So credit dashboard view model is going to be consuming from the retrieve credit draft list interactor. And it's going to create this live data. I've also represented it like a stream because it's kind of something. It's an object that is going to change, and it can be seen as a stream somehow. So yeah, the little robots are in the components, the Android architecture component. So the view model is an Android architecture component, the live data as well. So first step, designing the view entities. I believe this is the most important step in the presentation layer, because the idea is that we serve the fragment with objects that are very, very easy to consume. So the view doesn't have to do any further business logic. It doesn't, there is no logic there. It's just, it has to be as easy as possible to just set the view with whatever object we provide. So in this case, we have several of those little elements. And this is the object that we get from the domain layer, the credit draft. And yes, somehow we could work our way to build a view, but it's not really designed for it. So why not we just not create one that is fully designed for this view? So it's going to be called in repayment card view entity. And it has everything is formatted, it's a string because that's what we need, and so on. So it looks much better, and you can see how this Pojo maps to the view way easier. So now we have a list of these things, right? And this is going to go into the recycle view. And this is just an implementation detail, but it's important to understand the next steps, that our adapter is taking displayable items. It's not taking the view entity that we just created. But don't worry, this display item is something very simple. It's just an object where we wrap the stuff that we want to present in a list. So it has a type, so the adapter can know which type of view holder should use. And it has the model. In this case, it's going to be this view entity model. All right, so we have to map now. We have to do the mapping step. So this mapping step is going to have two steps. We have the interactor that is emitting these credit draft objects. And we have to first convert the credit draft object into a view entity, the view entity that I just showed. And then we have to wrap it in a displayable item for the list. So we can have that mapper, and yeah, again, it's a function. It has a list credit draft as an input and list of displayable item as an output. Next step is the view model. So in the view model, we are going to put everything together. We are going to connect everything and expose live data for the fragment to consume. But one thing to note here is that last line where we're going to bind the view model to the credit drafts. What do we mean exactly by this? Let's see. So we have this bind to credit drafts method, which starts in the interactor, of course. And then we map it with this mapper that we just saw. And then we subscribe. And in the subscription, we're going to feed the live data. That's all. We just post the value. The live data is live data of list of displayable item, because that's what the view needs. So yeah, pretty straightforward. But this is creating a disposable. This disposable we need to take care of. We need to dispose it at some point. So we are adding this disposable to this composite disposable, just in case we need more to bind to more other types of data or interactors. And then there is this method in the view model. This is this view model is part of the Android architecture components. So they say they are going to call the onClear method whenever the view model is not going to be used anymore. So this is a safe place where you can dispose this type of disposables. All right, fourth step. So we're going to hook the view to the live data now. So yeah, this is fairly simple. We have this create dashboard fragment, and we have this, for instance, on activity created. And here we have the view model get displayable item list live data, which is going to change every time, well, as you saw, all the reactive chain changes. And we're going to observe this and update the adapter. Yeah, pretty simple. So we're done with our feature. We saw it from the store up to the view, how it works. And okay, so I know the talk is pretty abstract, and probably there is a lot of questions, how to implement this, how to implement that, the reactive stores, the interactors. I didn't go very into details here. So that's why I created a couple of blog posts. There is a sample repository where you can see everything, how it's implemented and how it's built, if you are curious. And yeah, so I think I talked pretty fast. And there is some time now for questions, I guess. But how much time do I have? 15? Okay, then I'm going to just talk about a couple of things you need to take into account when dealing with this type of system, of reactive system. It's a couple of slides I just took out because I thought I wouldn't have enough time. So the first thing to note here is that this is a fully asynchronous system. And what this means is that you need to be careful with race conditions, concurrency, and all this type of stuff. So it's also an event-based system. So just don't break the rules for event-based systems. This means respect that the scope of an event is inside the chain and inside the function where you're dealing with. Every time you take that state and take it out and put it somewhere else, you are creating a risk, basically. And it's not necessary, actually, because RxJava provides so many different operators, even operators with memory. So you don't really need to do this and should be avoided because, yeah, it can lead to problems. Yeah, that was one thing I wanted to talk about. And I think that's it. So, yeah, if you have questions.
Come on, don't be shy. Surely you have questions, and there is some micros that you can use.
Hello, does it work? Do you hear me? Okay. In this example, if the backend gives you an error, or the API gives you an error, yeah, it's delegated to the view, right?
Yes.
So in this case, you need to resubscribe.
Yes.
Okay.
Yes.
Because there are other approaches to also wrap this error in extra state, so that you don't need to resubscribe to the.
Yeah, you can do it like that as well. It depends how you design your interactors, really. But you could have interactors like serve the state, like it's loading, it's error, you know.
Yeah.
But this also works because you have operators like retry in Rx.
Yeah.
That will resubscribe. So you can have a pretty solid strategy doing this as well. Even if the subscription ends because the error will end it, you have operators to deal with this and to have a strategy how to resubscribe through this retry operator, for instance. Yeah.
Hello. Okay. Hi. So my question is, I see like a lot of developers do not advocate like putting data in the lifecycle methods, and whenever they use MEVM model, they put it always in the view model and bind everything from the view model. And I also do it that way, and I think like the number of crash rates, everything has improved So have you considered this? What do you think about having data in the lifecycle methods? Are you still okay with this? Because I see that that's how you guys are doing it.
So what did you mean having data in the lifecycle methods?
Like the way you bind it is you do it on activity created, like
Yeah, here.
tell the adapter you use an observable and
Yes.
so like it's still on activity created, which is a lifecycle method.
Yes.
You're providing the view to bind the data. But if you use bindings, you can completely
you mean data
abstract
bindings?
it. Yeah.
Yeah.
What do you think about it? Because I see that,
Yeah.
yeah.
So, I haven't personally used data binding.
Okay.
I know the concept and kind of know how it works.
Right.
My understanding is that data binding, if you need to do something a little bit more custom, it gets a little bit more complicated, or you need to do some extra work there. Is that right?
I mean, for most things, it's really simple to actually use data binding. In my opinion, of course. But if there's like really a very special case, then of course you have to use something by yourself. But as of now, I have seen like even using multiple recycler views and handling scrolls, etc., was like not so hard.
Yep.
But
So
yeah,
yeah,
it's just
I
one
think
thing
that's a totally valid solution as well. And
Yeah.
the only thing I wanted to point out, because if I understood correctly, you said that this can crash or
No, I
here?
didn't say it would
Or
crash.
if there is an error, but if
Yeah,
there is
it's
an
really
error.
hard to like, I think that the number of crashes has reduced like exponentially because it abstracts out the human error part and you don't have to always check for nulls and things like that. So
here, if you check that part, it's almost everything relying on the framework, right? Because this get displayable item list live data is giving this live data object, so that's kind of Android framework, and they have to take care of it.
I know. I also have done it that way. I'm just was curious. And another thing is, are you using RxJava 2 or?
In this example, yes, we are. This is all RxJava 2.
Sorry, that's a stupid question. Anyway, why are you using like Flowable? Because are you expecting more than 1,000 objects at a time?
No, but when I checked the documentation, it said that if you're going to do a long asynchronous operation, like it could be an API call, for instance, that blocks, then you don't really, like one of the reasons is if you have more than, I don't know how many events coming for the back pressure.
Yeah.
And the other one is if you are going to block it for a long time, then you also have this risk because, of course, if there is, you don't need 100,000, you just need some coming during this, blocking period. So I just follow the documentation and the recommendations there that for, API calls, it's better to use the Flowable.
Okay. I mean, I actually think it's not required to use Flowable there because observable is good enough because at a time you don't receive so much. Only if you need to support back pressure strategy, then you need like a Flowable. Okay. And you do not really cache so much at a time, I think. So, I mean, I was thinking probably the credit list is like huge and,
no, it's actually very small. Okay. And probably is not even required for this specific example. Like as you said, probably observable is good enough.
Yeah.
And Flowable has some overhead, right? So it's probably a little bit slower.
Yeah.
When you use it.
And one more thing is like, you could also use maybe instead of option because now RxJava 2 actually has given you the option of using maybe where you can. It's kind of a replacement for optional, I think, because before I used to use optional, but I don't know how you feel. So I would like to know, like, if you tried it and.
So the problem with the maybe is that it completes.
Yeah.
And the requirement for my streams is that they shouldn't complete.
I mean, you can either make it complete or not make it complete, depending on if it's none, then you don't make it complete. and if it's not null, then you make it complete.
So
I think that's how it works.
Then maybe if there is no value, then it just completes. That's my understanding. It doesn't emit anything. It just
no,
completes.
you can actually.
Or it emits.
You can say that it should not complete if there is no value.
All right.
Like you could use it.
I'll check it out then.
Yeah.
It might be better. Yes.
Yeah. All right. Cool.
Okay, thank you.